In this video, we're going to look at how to determine a reaction mechanism. So the steps of a reaction mechanism, the elementary steps, must satisfy two requirements. First, the sum of the elementary steps must equal or add up to the overall balanced chemical equation. And second, the rate law for the overall reaction must be the same as the rate law for the slowest elementary step, also called the rate determining step. So be sure you make a note of these two steps and you understand what we're saying here. So let's apply that. Let's look at a problem. Here we have a balanced chemical equation. You can see the stoichiometry, which is very important. And let's say experimentally, we determine the rate law for this reaction to be as follows. So it's second order with respect to nitrogen dioxide. Here's two possible mechanisms for this chemical reaction, mechanism 1 and mechanism 2. Take a minute and study these mechanisms. Keep in mind the two steps that we just mentioned in the previous slide, and see if you can determine which of these mechanisms is most likely a correct mechanism for this reaction. Pause the video and give it a try. Okay, so first, let's see if both of these add up to give us our overall equation. Here I have an intermediate, my atomic oxygen cancels, and if I add these up, I get 2 NO2s, yields 2 NOs plus O2. That gives me my overall equation, so that's possibly correct. Mechanism 2, do we have any intermediates? Yes, nitrogen trioxide, so we can cancel that. And we get 2 NO2s plus 2 NOs plus O2. So both of these fulfill our first requirement. They add up to give us our overall equation. Now let's look at the rate laws. What's the rate law for this first mechanism? Well, for the slowest elementary step, the rate law would be rate is equal to K times the concentration of NO2 to the first order. Well, that doesn't fit. Over here, you can see we have the rate law here to the first order. The rate law for the second one, we look at our rate determining step. Rate is equal to K times concentration of NO2 to the second order. Well, that's the same as the rate law that we determined experimentally. So mechanism 1 is not a possible mechanism because the rate law doesn't match. Remember, we can use the stoichiometry to determine the order if we're talking about elementary steps. We can't do that for the overall reaction. So possible mechanism 2 is most likely correct. Let's take a look at a more challenging problem. Here, you're given the following balanced chemical equation, and you're given the rate law, which was determined experimentally for this reaction. See if you can propose a possible mechanism. So propose a couple of elementary steps that would meet that criteria that we talked about previously. Pause the video and give it a try. Okay, so let's take a look and see if we can figure out a mechanism. What do we know? Well, the first thing I'm going to look at is I'm going to use the rate law. The rate law, I'm going to use that to determine the reactants for the first rate determining step. So I'm going to assume my rate determining step is the first elementary step. It doesn't have to be, but I'm going to assume the rate law is the first elementary step. And then I can use my rate law to give me the reactants. So my reactants would be hydrogen, H2, and ICl. So I'm going to put those down as the reactants for my first elementary step. Now, very important, it's first order with respect to hydrogen and first order with respect to ICl. So my stoichiometry here must be 1 plus 1. Okay, if this was second order with respect to hydrogen, then I'd have a 2 here. So the stoichiometry here cannot change. It's very critical that you appreciate why that is. So where do we go next? Well, we have to predict our products. How can we predict our products? Well, let's look at our overall equation. Our equation tells us that I2 must be one of our products. Could I2 be a product here? It could not, because I only have one iodine. I don't have two, and I cannot change my stoichiometry. So I could not put I2 as a product. What about HCl? Could that be a product? Yes, I have an H and a Cl, so HCl could be one of my products. If HCl is a product, what would my other product be? Well, if I use HCl, then I've got another hydrogen and another iodide. So maybe my products would be HCl would be one of them. HI would be my other product because that's what I have left over. Remember, I cannot put a 2HCl here because that would make me change my stoichiometry over here on the reactant side. And I cannot do that or it would affect my rate law. So again, be very careful not to change your stoichiometry because that will alter your rate law. Step 3, use the overall chemical equation to help predict the reactants for the second elementary step. So my second elementary step, let's see, I need another ICl. See, I need 2 of those. I only have 1 here, so my second elementary step must give me another ICl. Also, what else do we know? I noticed that HI, that doesn't appear in my overall equation, so HI must be an intermediate. So my 2 products, or my 2 reactants rather, would most likely be HI and ICl. HI is an intermediate, so if we form it in one step, we have to have it over here so it would cancel out. Because remember, our overall equation, our elementary steps must add up to give us the overall equation. Now, 4th step, we need to get the products for our second elementary steps. Now, what could they be? Well, again, let's look back up here. We need I2 as one of our products. Here we have an iodine and iodine, so we could put I2. And what else would we have left over? We would have HCl. Well, that's what we need. So let's go with I2 and HCl. So both of these elementary steps are balanced chemical equations. Be sure to check that we have 1 hydrogen, 2 iodides, 1 Cl, 1. So all of these are balanced chemical equations, and they must add up to give us our overall chemical equation. So let's check that. Let's check to be sure that our mechanisms, our elementary steps, add up to give us the overall chemical equation. And we also need to check that the rate law for our rate determining step must be the same as the rate law that was determined experimentally for the overall equation. So these are the 2 criteria that we said any mechanism must meet. So let's check that. Do these add up to give us our overall equation? Well, here we have our intermediate will cancel. And if we add those together, yes, we do get the overall equation. And let's look at the rate law. Let's say that our first step is the rate determining step. Our rate law would be rate is equal to K times H2 to the first order times the concentration of ICl to the first order. So here, these 2 rate laws match. So we do have a possible correct mechanism here that we've proposed. So let's take a look at one more problem. Pause the video and see if you can predict a possible reaction mechanism for this rather complicated looking chemical reaction. Pause the video and give it a try. So let's take a look at those steps that we went over before and follow those, see if they'll help us. First, let's use our rate law to determine the reactant or reactants for the first step. Let's assume our first step is a rate determining step. So that would mean that this must be my reactant and it's first order with respect to this reactant. So my reactant would be as follows. And again, the stoichiometry here is a 1. If it was second order, there'd be a 2 here, but we cannot change that stoichiometry. So now we need to predict a product. Let's look at our products that we have up here. Which of these could be a possible product? Could the first one be a possible product? No, it could not, because we have iodine, and we don't have any iodine here, so we can't change the reactants. What about water? Water could be a possible product, so what would we have then? If we broke water off, what would we be left with? COCN5 with a -2 charge. So these could be my possible products for my first elementary rate determining step. Well, let's take a look at the third step. Use our overall chemical equation to help us predict the reactants for the second elementary step. Well, somehow we've got to get iodine in here, so we have to have I- most likely as a reactant. And this guy, cobalt tetracyanide, this is not in our overall chemical equation. So this must be an intermediate. and so we need it to cancel out. So iodine, I minus, or iodide, I minus, and this must be my two reactants. That, that way, this intermediate, we can get that to cancel. Well, now we need to predict our product for our last step. Again, let's look at our overall equation to help us with that. Well, now this could be one of our steps. We have COCN5 2 minus and I minus. If we put those together, we should get this product, and we do need that. So we have a possible mechanism. Let's check it to see if it works out. The first rate determining step, what would be the rate law? Well, the rate would be equal to K times the reactant here to the first order, and that matches up with the rate law for my overall equation. And do these add up to give us the overall equation? Well, let's cancel out any intermediates, and let's add up what we have left. If we add these together, it does indeed give us our overall chemical equation. So this would be a possible mechanism. So be sure you understand these steps and can follow them in order to propose a possible mechanism given information like we have here.